In this video, we're going to find the inverse of two functions here. Now, by definition, a function is such that for every x, there is only one y. Not every function is going to have an inverse function. It might have an inverse, but the inverse won't be a function. For example, a parabola that opens up is a function. The vertical line test will assure this. Any vertical line will cross this graph at one point. That tells you for every x there's one y. But if you take the inverse of that function, you get a parabola that opens sideways. I draw a vertical line here, it crosses it at 2 points. So that tells me for any given value of x here, there's two values of y. So the inverse is not a function. Now if the function is 1-to-1, that means for every x there's one y, and for every y there's one x, then the inverse will be a function. For example, exponential functions are 1-to-1. Logarithmic functions are 1-to-1. And this is the way it works. If you have a function f denoted by f of x, say this is a function, and you take any ordered pair, and of course any function will have an infinite number of ordered pairs. You take any ordered pair, x, y, then this will imply that the ordered pair yx, in other words, if you reverse the ordered pairs, that point will be contained on the inverse, which is denoted by f to the negative 1. And that's not an exponent, that's read f inverse. So again, if I take any point on the graph of f of x and reverse the ordered pair there and say y, x, that point would be on the inverse. So this is the way it works. Easier to work with y than f of x here for the substitution here, so let's just rewrite this as y equal 3x minus 5. This is a slanted line. Goes something like that. It's 1-to-1 because first of all, it's a function because any vertical line is going to cross it at one point, and any horizontal line will cross it at one point. Not the same case for a parabola, for example. So I know the inverse is going to be a function. Now, to find the inverse, all you have to do, if you're given something like this, is interchange the x and the y. So where I have a y, I put an x. Where I have an x, I put a y. And then I solve it for y. So this will be x. Add 5 to both sides, it cancels it over here. I get a plus 5. I get 3 over y. And I solve for y. So divide here by 3. Divide here by 3. So the inverse here would be y equal to x plus 5 over 3. And then I go back to the notation. Instead of the y, I'll use f inverse to denote that this is a function. F inverse will equal to x plus 5 over 3. And this is the inverse function. So again, if you're given a function and you're able to reverse all the ordered pairs, you generate the graph of the inverse. Now in this case, I'm doing it algebraically to get the notation or the inverse function. So to find the inverse function of a given function, write it this way. Instead of the f, write it with y here. If it's given to you like this, just write it with a y. Same thing, but this is more convenient. Now once you have it in this format, solve for y, then just interchange the x and the y. Where you have a y, put an x, and when you have an x, put a y, and then the third step is to solve for y. And this could be y equal to this, but using the function notation, I write the f inverse is this. Now let's kind of check it here. Pick a value for x, any value for x here, let's say 1. We'll put it here, 1 times 3 is 3, 3 minus 5 is a negative 2. So negative 2 should be, if you graph this line, 1, negative 2 should be on the graph of that line. Now, from what I said then, if I reverse the ordered pair, 1, negative 2 is on the graph of the function, then negative 2 and 1 should be on the graph of the inverse. Let's check it. Let's put a negative 2 here where the x is. Negative 2 and 5 is 3. 3 divided by 3 does give me a 1. So this checks out. There it is. Now for the next one, same sort of thing. I replace the f of x by y. I got the log to base 3 of x minus 2 plus 4. So now, the next step. Interchange the x and the y. So I have a y, I put an x. That has the effect of reversing the ordered pairs. So I get this. Plus the 4. Okay? All I did is replace the y by x and the x by y. Again, that's interchanging the x and the y. And then you just solve it for y. So this is a log expression, so we have to use some properties of log. So first, let's add negative 4 to both sides. Negative 4 added over here, then negative 4 added to the right side cancels that. So I simply get this. Log to base 3 of y minus. Now I have to solve it for the y. So I'm use the definition of log. If you have the log of some expression equal to some value, which is the actual log, in this case it's a variable x minus 4, it means that this expression here, so in this case that's y minus 2, is always going to equal to this base 3 taken to this power over here. So this would be 3 x minus 4 power. And then I solve it for y. So I add 2 to both sides here. And the y is going to get the 2 minus 2 and the 2 cancel. So when I get a y on the right side, I'm going to write it as f of x. Or I should say f inverse of x. I could do it with y. But generally when they give you these types of problems, they want to use the functional notation. F of x or inverse f of x. So I get f inverse of x then is equal to, adding 2 to both sides here, so this will be 3 to the x minus 4. So it's going to be 3 to the x minus 4 plus 2. That's the inverse function. Now let's check it. Let's pick a point on this one here. So let's see, this is the original function. So I want something that will come out as an exact answer, so I don't have to use a calculator. So let's pick 11. Let's let x be 11. Put 11 right there. 11 minus 2 is 9. And the log of 9 to base 3 is 2, because 3 squared is 9. So this gives me 2. Again, put 11 right here. 11 minus 2. So I'm putting 11. So that's the x. And then 11 minus 2 is 9. Log of 9 to base 3 is 2, because 2 squared is 9. And then 4 more gives me 6. So the point 11, 6 is on this graph right here. So if I reverse the components of that point and make this 6, 11, based on what we said, this point should be on the graph of the inverse. So let's test it out. Put a 6 there where the x is. 6 minus 4 is 2. 3 squared is 9. And 2 more does give me 11. So that checks out. Thanks for watching. We'll see you next time.